Morning Year 12s. Here's a little bit of a video to explain critical regions with hypothesis testing. Just to understand, critical region is just a set of values which are significant under the null hypothesis. You use the binomial tables or the probability function on your calculator to find it. If the test is one-tailed, the critical region will be at one end of the distribution. If the test is two-tailed, the critical region will be split in two with a bit on each end. The critical region is a collection of values under which the null hypothesis can get rejected. So it's known as the rejection region. And that's where, instead of you going each of the values, you find that one region and then you answer the questions according to that. So this can sometimes be used as an alternative method rather than finding for the exact value that you're given out of a sample. So I'll use this particular example that I've got in front of you to do both of the methods. Part A looks at your normal method that you've been taught already in the previous lesson. Part B looks at the critical region method. Okay, so without further ado, let's get started. A company manufactures kettles. Its records over the years show that 20% of its kettles will be faulty. Simon claims that the proportion of faulty kettles must be lower than this. He takes a sample of 30 kettles to test his claim. Now, what we're doing, I'm just going to draw a little bit of the region here. So if this is the distribution, let's say, 0 to 30 kettles, he's claiming that the proportion of faulty kettles will be lower than 20%. That means we're looking at this end. So this is a one-tailed test. So we're looking at the lower end of the whole of the region. So essentially, this value and any value below this will be in the critical region. And that value where it starts being the critical region is known as the critical value. And the whole of this area here is the critical region. So part A is Simon found that one kettle in a sample was faulty. State whether this is significant enough to reject the null hypothesis at the 5% significance level. So let's do our hypothesis test in the normal manner. So we write down the hypothesis. So the null hypothesis is that probability of kettles being faulty is 20%, 0.2. The alternative hypothesis, what Simon's claim is that the probability should be far lower than 20%, so 0.2. The significance level is 5%. So 0.05. That's just alpha. It just denotes the significance, the p level. You can leave it as p equals, actually no, don't write p as 0.05 because you've already claimed this as the probability. So leave that as alpha is 0.05, or you can just say significance level is 0.05. Now we need to find whether one kettle in a sample was faulty. That means if the critical value here is sort of 1 or less. If any of those values in the critical region, then the probability of that should be less than 0.05. So we do probability x is less than or equal to 1, and we find that out. So if we turn our calculator on, going to distribution, binomial, going into binomial cumulative distribution, and these are the values we're looking at. The lower bound is 0, the upper bound is 1, the number of trials, he's looking at 30 kettles, and the probability of success is 0.2. We press execute, and that comes to 0.010522249. Now this probability is less than our significance level. It's less than 0.05, which means then we conclude Therefore, there is sufficient evidence to reject the null hypothesis and accept Simon's claim that the proportion of faulty kettles is lower than 20%. So that's what we've given as our conclusion. The next method is to look at the critical region method. So part B says, find the critical region for a test of Simon's claim at the 5% level. That just means, so if we go back to our little diagram here, we found that 1, let's say somewhere here. So 1 is within the critical region. So if 1 kettle is faulty out of the 30, the proportion of kettles overall, we can say, yep, it's less than 20%. It's within the critical region. What we're trying to find out now is actually what is that critical value below which all of the number of kettles, we know if were found to be faulty out of 30, we could have rejected the claim. That's what we're trying to find out now. So we could really then answer all the questions after this question to do with critical region, just depending on the critical region, because we can then say, this value of number of kettles being faulty is in the rejection region. This number of faulty kettles is within the acceptance region, and then your conclusions become really easy to follow. So critical region method is quite a nice one to do if you want to answer multiple questions consecutively after that. So let's find the critical region for a test of Simon's claim at the 5% level. This is where you try and use your calculator to see where the probability would go below 0.05. Okay, so if I write these down, we know that the probability of x is less than or equal to 1 is 0.1, 0.0105, 2249. So this is in the the rejection region. The next one we would need to find is probability x is less than or equal to 2 and see if that's also within our rejection region. So we go back to the calculator, we make the upper bound 2 now, and we press execute. And we can see there that's actually quite close to our significance level, which is 0.05. So if I just write that down. So this is still within the rejection region. Then we find probability x is less than or equal to 3. Make the upper bound 3, and here we find the probability of out of 30 kettles, 3 or less kettles being faulty exceeds our rejection region criteria, which the significance level is 0.05. So what we've found as a result of that is the critical region is x is less than or equal to 2. That means 2 or less kettles being found faulty out of 30 would be significant enough for us to reject Simon's claim that the proportion of faulty kettles must be lower than 20%. The critical value is 2, because below that number is when, and equal to that number is when the critical region starts. Okay, so that's how we do the critical region questions. We go through our table or we go through our calculator and we find where we would be, what set of values would allow us to reject our null hypothesis. I'm going to do next video on a two-tailed test, and we can then look at significance level and critical regions in those ones. Hope that helps.